Hello, Chris.
How's it going?
Good.
It looks like Angel Island behind you.
What do you mean?
Whoa, good morning.
Good morning.
Good morning. I'm in the car, so I'm going to leave the video off.
Okay. Just give people another couple of minutes to join before we start. So Chris, while we're waiting for people to join, regarding this last email you sent to Bill Fisher, can you fill me in on what we hope to accomplish? Because he's been non-responsive, hasn't he? Yeah, I'll give us just a couple more minutes to Hi, Sal. So Chris, I had a quick question for you. Can you hear me? Okay, I cannot hear you. You're on mute.
Sorry, I hear you. I thought I was off mute. I was in a public space, so I was moving to a quieter spot.
Okay.
Yeah, what I'm hoping to accomplish is, so first of all, he did respond once, so it's not complete radio silence.
Okay.
But I also talked to other people at NIST, and my understanding is that these special publications from the NCCOE, as you had noted, are driven largely by industry members, and as you point out, by the time we get to see a call for input, it's too late to have a material impact. So what I'm hoping is that we can get him or his delegate or somebody there to explain how CCC members can be more involved in initiating those papers in the first place and driving them.
Right.
So I wanted to get his sort of advice. All right, you guys say you want to see more prominent discussion of confidential computing. Here's how you would go about doing it, and then we can raise those ideas to our membership and see who can get more direct, who has the bandwidth to get more directly involved in proposing things in the first place instead of just to responding to them after they're already shaped by other companies.
Okay. Fair enough. Well, let's wait for him to respond. Okay. Hello, everyone. We're going to kick off our meeting today. Welcome. I noticed that for the first time, I got a pop-up saying this meeting is being recorded. So I need to figure out where is this recording, how we're going to link to it from our meeting minutes, how we're going to like maybe surface these recordings from the consortium's main site, like the attestation SIG, and everybody else already does.
I'll make a quick note of that. I think with the LFX platform now, that will all be automatic. So I don't think we have to worry about the logistics of uploading. I do think now that it's all LFX standardized, the one thing that we probably should do is just make sure in our slides we have the code of conduct at the beginning of the recordings. But otherwise, all the same, no extra effort for us. It'll all get uploaded automatically, but I'll make sure.
Okay, well, if we need to, if there is a requirement around code of conduct and other things to start every meeting off with, perhaps you can help us set that up.
And we'll do.
All right, thank you, Sal. All right, so I have 3 things that I'd like to go over today. And as usual, now is a good time to bring up any sort of agenda item that you may have. But my first one is I would like to move our confidential payload governance pattern document closer to final stage where we can take it to the TAC, collect final inputs, and sort of I would like to sign off on it, ideally before the end of May. Second thing is I would like to then move on to the other pattern that is shorter, fairly straightforward, I think. But again, I'd like to get to a point where we, consider it good enough to do a final review with the TAC and move on. I would like to discuss the warrantless surveillance legislation that is going on right now, and to what extent confidential computing may have play a role in a world where just being a simple custodian of a data processing device may allow government to get information out of that device, not inform the owner, compel whoever is in possession of the device to do exactly that. Confidential computing seems to be positioned to mitigate at least some of the concerns that might result from that. And I think perhaps then we can talk about which of the governance patterns we can attack after the two we have in flight are ready. So we can start doing preliminary work on that. So that's it for me. I just want to open the floor to anyone else who wants to add anything to the agenda.
I think that sounds good.
All right. In that case, let me start sharing my screen. So we had the document I'm showing. We did a fair amount of work on it yesterday in our joint working group with the CSA, but a little bit of work remains. So let's see how far we can get to getting this resolved, so we can move on. All right. So can you see my screen? Do you need me to zoom in any more than I already have?
Looks good to me.
All right, sounds good. So I'm going to scroll up, and if there is a glossary, Sal, that's perhaps a good question to you. I would like to be able to reference it here, because we talk about, we should always seek to use as few terms as possible and use them consistently to avoid confusion.
Yeah, completely agreed. This is something that we need to bring up again formally, and I probably need to get in writing. There's been concern from CCC about making a glossary due to non-shared or standardized definitions, but
yeah, but we can have our own definitions, and then we can map them to the definitions that may be used outside, but we still need a language in which we communicate.
Agreed. Yeah, horse and cart problem. So
right.
I will follow up on this again.
Yeah, so like even as simple as this document talks about confidential payloads, and that the term of a payload is perhaps in keeping with what we are have done in our sort of, remember the earlier document that we've done where we just talked about sort of governance in general, and we talked about like payload and payload slices. The second document we'll be looking at today, hopefully we'll get to it, is about workload upgrades. And now we're talking about not just payload upgrade, but workload upgrade. Okay, so they're actually not the same in my mind. And we should be very careful to make sure that the readers of these documents share our understanding of what we're talking about. So this is like more and more reasons to talk about. Let me put in chat the link to this document that we're looking at right now. And what I would like to do, let's spend the next 10 minutes, let's like read over it and pay particular attention to the comments that already have been made, so we can perhaps attempt to resolve them. And again, it's not a long document. It's and there is a big to-do here. We need to finish writing the third part of the solutions, and we need to write down the expectations of personas. These are the big unfinished items, as in like they're glaring omissions, but they should not take long to fill in. But that's what needs to be done before we call it done. So I'm gonna go on mute for say 10 minutes, and we'll go at 20 past the hour to review feedback. Okay, I think we're ready to proceed. So I went through, made a few changes. We can go in order of comments made, or if anyone has anything they'd like to share right away, now's a good time to bring it up.
Okay, I'm driving at the moment, Mark, but could you define the difference between workload and payload?
Yes. So if you remember, we talked about, so I go and I develop an application. An application may not run just on a CPU, but also perhaps on a GPU, right? And as a result, this is why we invented the terms payload and the payload slice. So basically, I think generally what we meant by that is when you deploy a payload, you're going to deploy it on a device, but the device may be made up of multiple components, and you deploy different slices into different Ts, and those Ts need to cooperate. Now, a workload is looking from the outside on processing of some sort. So, maybe you establish a TLS connection to some sort of a load balancer, and the load balancer terminates TLS and then moves the payload, the payload in the sense of, the command sent by TLS over to some sort of a, middle tier, and then perhaps doing some processing on the back end. The workload is an identity of several cooperating devices that may work in concert to deliver certain functionality.
Okay, so you've got one being defined as what runs in the actual TEE, the payload slices. You have one that is the external point of view. I want to talk to a single entity. It may be multiple entities behind the scenes.
Yeah, so right. So the way, I mean, and maybe there is some problem with the definition I'm proposing, and we can discuss, but I'm basically saying payload slice runs in a T, a payload runs on a device, and a workload spans devices.
Maybe that just needs to be added to the document somewhere.
But that's why I'm saying we need a glossary. So because we're going to be using the same terms for multiple places, and if you don't put it in a central place, you're going to have inevitable diversions.
Well, I guess my comment is first, if you want to go in order, it actually is kind of a meta comment, which is that I think a lot of people assume that you can take existing applications without much modification and just lift and shift them into the cloud or someplace and get security out of it. And I understand that confidential VMs make that easier to do, but it's also fundamentally less secure than actually sitting down to think about how to minimize your TCB and refactoring your application. So,
yes,
SGX was the first thing. It's really hard for people to do. Now it's a little easier with confidential VMs, but it just also allows for sloppiness. And I feel like throughout this document, this notion of repartitioning is not sort of directly tackled head on. And I feel like we need to educate people about the difference between lift and shift and, directly architecting a workload and a payload for confidential computing.
I agree with you. It is. Yeah, we kind of talk about like almost like nibbling around the edges here. We're saying, well, make sure you generate the right random number. We talk about you use, make sure that your traffic to and from is properly secured, which even confidential VM is not going to do anything against, right? So those are very generally applicable. What you're suggesting is an even deeper look, right? Saying, you might want to also consider as you move into a confidential computing environment, like what, and I think it makes for a decent should requirement. I encourage you to then switch to reviewing mode and suggest, a set of changes. So I would put something into into forces saying TCBs are too large, right? Make another bullet. The alternatives, potential vulnerabilities here might be, you know, you're pulling in things into your TCB that really do not play, you know, don't really do you a service, right? And then you can suggest under solutions how you address that particular thing. It's too large of a suggestion to be able to, like, you know, wordsmith it and put it in online, like when as we are right now. But as we meet again, you know, we should talk about that. I think our next meeting falls during the week of RSA, so we should probably you know, skip one. But we can then take a look and, you know, review and accept your changes. I'm generally in agreement with you.
I'm wondering if we can reference some of the SOA architectural work. I mean, it's moving out of our domain a bit, but Chris, to your point, the smaller the TCB in general, the less exposure and risk you have, right? So just because you can put entire machines into a confidential VM doesn't mean that that's what you should do from a security point of view. Not that we want to then get into SOA ourselves, but we can reference microservices versus a monolithic app. You're going to gain even more benefits from a security perspective with TEEs in payload slices, payloads, and workloads.
Yeah, I've got one note to this. I think one, all of this absolutely has to be included in the set of patterns that we create. We should be thinking about these as like composable, sort of like 2-page documents that fits very specific scopes. What I want us to do is make sure that we have the discussion and make sure that we have the lead-in on this, because it's basically the lead-in for these patterns, but there's no reason to do these patterns if you don't have control of the surface area of your TCB, right? So I think that there should be a short pattern before this that we do seriously lean on the good work that has been done before. But I want someone to be able to pick this up at as a set of basically pre-manuals before they start to create a architectural model and a threat model. So I think we should go a little bit more into depth on the TCB on a document right before this, but I think I can best design that if you give me a couple more notes on this page and we know exactly how that fits into this, which would be stage 2, I think. Does anyone disagree?
I actually don't understand quite what you said.
So I guess this is so open for discussion, and I think maybe it's a misunderstanding of mine. Do you think that this sort of the recommendation of having, I'm just going to call it a small surface area, right? Make sure that you don't shove massive things that you don't have control over into this. I guess, actually, can I drop us down to a discussion underneath here? Because I get there are 2 slightly different discussions, and for me, it would bring a lot of clarity. There's a comment down on this that says, we want to do basically good vulnerability management, but it's only a recommendation unless you have very good control mechanisms for that within the TEE. Now that's different to what we're discussing right now, right? What we're talking about right now is bringing in things that have not been correctly modified for the TEE space. They haven't been like security considered architecturally. Is that at this stage of looking at the TCB? Or perhaps someone
I
can.
think so. I think actually that is related. You know, I think people who are building modern applications are generally aware of the importance of minimizing the TCB and encrypting I/O channels and the data that goes to disk or other parts of the network. So I think, you know, to first order, a lot of people are trying to do security best practices. But this issue of minimizing the TCB is actually sort of very fundamentally connected to the concept of confidential computing, because there are multiple workload scope Ts, because there's a difference between confidential VMs and confidential processes that's introduced by history and technology. I think that it's important to address why that distinction matters. And it's important for people to recognize that even though we have now got the confidential VM paradigm, it doesn't mean that you shouldn't still be thinking in terms of confidential processes and careful factoring of your workloads. So there's a very direct issue that is an opportunity that's raised by confidential computing that I think is worth calling out separately.
Thank you. That's a really good way to think about it.
Okay, so again, I encourage you to write your suggestions and then let's review. So we can also move on. I would like to then very quickly go through, Alec, your comments here when you say consider other devices. Yes, I'm inclined to accept this. And I like your edit, data exchanges to network storage and other accelerators. That's, I think, it's a great suggestion. So unless there are objections, I'm going to accept those. Okay, hearing none.
I went on mute before I went to the door, so even though I was talking through my wireless, you couldn't hear me. But yeah,
No.
cool. We're
Okay.
working on, TDISP and SPDM and IDE and all of those things as we bring more devices into the T.
Yeah.
And so we need to make sure the document reflects that.
Yes. Okay. Okay, let's see what other comments we have in place. So, Chris, I'm going to reply to this. So the reader of the document, can I just say Chris will suggest new language under forces and solutions?
Sure.
We'll discuss in our next meeting. So we're just going to leave this comment open while this is going on. Steve, I would like to speak to Mark Bauer's comment here. So when we talk about things you need to do when moving code into a computing environment, now your particular solution, Anjuna, basically says we're going to handle some of that for you, right? So this is where you'll say, okay, the runtime environment explicitly and verifiably manages this, which is correct. It's both correct and a bit of a one-off, like you have a thing that you're offering that most others don't. So I wondering how to bring this in into the language of the document. We could do that as a footnote, or we could, but like we need to remain vendor neutral.
You want to put it as a footnote for now? I can't, I'm driving, so I can't read the screen, but I can review it later.
What I'm going to do is I'm going to I will basically say Anjuna folks will add a footnote explaining. Okay, so I'm gonna leave it to you guys to say how you want to say it.
Okay.
But I will add the other thing. I will say the resulting text must remain vendor neutral. So just please stay to that. All right. Thank you for that suggestion. Insecure generation of random numbers. Again, not my first language, but I think insecure is unsure of yourself. Kind of thing that, makes you do poorly on a date, but it has nothing to do with random number generation. Is there a better word? Unsecure.
Unsecure works for me.
Or less than secure.
Or do you want to use, what's inside the TEE is trusted, what's outside the TEE is untrusted. You want your random number generator to be generated from trusted codes.
Well, but that's, we're saying the forces here is the fact that you may choose a poor source of randomness. How about I will just say use of a poor source of randomness in generation of random numbers of entropy. That's probably even correct.
I think that's better. Yeah.
Okay, great. All right. So we're still waiting on Simon for automatic generation of configuration. This is a to-do that will be resolved around using musts, shoulds, etc. Okay, delete. Okay. Oops, shit, what did I just do? I should accept your change, but we need to insert a space. This is where Alec added configuration settings delivered ancillary files in the to generated binary. So basically, all output of the compiler needs to be signed.
It's not, so, sorry, what we're running into is that when you have binaries, that when you add extensions or packages onto an operating system or
Yeah.
applications for that
Yeah.
matter, the binaries you can sign, and that's cool. And so you can have good, guarantees of provenance and tamper resistance
Yeah.
in the binaries. But then there's all these config files that are just plain text files, and there's scripts that are entry points that you can't sign, and they can be tampered with. So if you've got the entry point that calls the binary with a command line that references a config file, the binary might be sound, but the entry point script and the config files can be tampered to make the whole damn application insecure. Unsecure.
Yeah.
Can make it insecure too.
Right.
A lot of things.
Okay. But yeah, I like your edit. It was a good thing to add. Again, if anyone else on the call wants to propose another change, please go ahead. You can do that in real time. Finally, before we sort of move off of this, so Mark Bauer made a comment saying that we should explain why trusted root stores are essential for risk management, and I'm inclined to. It's a worthwhile addition, but it actually the reasoning belongs in forces section. Solution should just basically saying do these things to address your problems and forces. So good to just change wrong section. So again, Steve, perhaps you and Mark can go and do that edit so we can move on here.
Yeah, you can just tag me and I'll catch it later.
Okay.
I do agree completely with Mark Bauer's language, though. I'd like to use that exactly when we explain the forces.
Yeah, it's great. So, but we can also push this offline. All right. So again, so Sal, you started originally on this document, so I just perhaps want to see if you're willing to do a few final things before we move on. One is I'd like to make sure that this integration, configuration, and deployment section is basically done. And it still has a couple of things. So we already talked about security settings configuration as part of remote attestation. We kind of mentioned it under trusted root store and cryptography choices, but perhaps add a few more words about any other security sensitive stuff, also included in remote attestation, blah blah. And secure provisioning of keys, also an important thing that you need to do. So I do not know if it goes under code development or if it goes under in the configuration, like in deployment, but these still need to be addressed, and we just won't be able to do them in real time here. But maybe you can take a look, and maybe you and I can work offline, propose a few changes. Because again, next time we meet, I would like this to be the final version.
Yeah.
Can
agreed.
you give a little context on what you mean by security sensitive configuration as part of remote attestation?
Yes.
Because there's
so
especially I'm especially curious about things that aren't part of the platform, right? Like we know we can attest hardware. The attestation report that's provided by the CPU vendors that's simple.
Yeah.
But then there's stuff that gets added like firmware that's part of the VM provisioning that is pre-boot, and the boot manager and all that stuff that you think about with measured boot. it's harder to make that part of attestation. And then when you get into things that are delivered with the OS, you know, Linux system D settings, how you make that part of attestation.
Right. So let's take the thing that just popped into my head and I'm somewhat familiar with, containers. So you fire up a container, and the container is an image. It will run anywhere. But with container, there comes some sort of metadata. It's actually configuration stuff that says, okay, in order to execute this container, you also need these metadata. Today, metadata actually may contain like plain text keys, right? And all sorts of other things that if you give it the wrong metadata, it may do wrong things, and in particular may do wrong things around security. And what we need to ensure is that whatever is security sensitive about the way this thing pops up needs to actually incorporate, you know, any configuration metadata that comes with it to properly attest it.
Okay. So containers are kind of easy, right? Because you can measure the whole container. But what about an operating system, like an honest to God operating system that loads into that's loaded into the VM by the bootloader?
Right. In that case, configuration. So configuration, if the configuration is part of your image, right, as it may be with a VM, then you're golden. Then
Okay,
you
so
just attest the image. But
with either a container or a image, right? You can always attach your root storage from the outside. You can always attack your configuration from the outside. So we do need to say that that should also be encrypted and part of the right. If you're bringing untrusted stuff in, you know, you can do anything. You can manipulate how the payload is going to function.
exactly.
So that's all got to be established as part of the root of trust. Now you can do that by putting in after attestation and then pulling in the files and then decrypting them on the fly. I mean, that's what we do out of the box, but there's lots of ways to get to that same place.
Yeah. Well, so the first bullet here already talks about, you know, ensuring that your trusted root store is the correct one. And then you know, if different instances of this image may run with different trusted root stores, you actually need to attest what your trusted root store is. But it covers that part.
I agree with that, but why single out the root store? It's the whole OS, right? The root stores.
Sure. Just a trusted root store is the, you know, the clearest example, one of the clearest, where you can really screw the pooch if you get it wrong. Like you'll establish TLS connections with wrong things. You'll be getting keys perhaps from the wrong key store. Like all sorts of things can go wrong. But it's by no means all encompassing. It's a clear example. Same with, like, you know, if my key like choices of ciphers and key lengths and modes are configurable. That's the second bullet, talks about that. And we can also make a third bullet saying any other security sensor configuration might likewise. But just calling out the things that are, you know, clear and present dangers, and other things that we may not have thought of need to be like a catch-all, like a wildcard bullet. That's the idea.
Sure, cool. I'm just thinking about, like, if you've got a Linux OS and you've got DM crypt enabled in the OS, or DM Verity, that's a config file that's delivered with the OS. Kind of,
sure.
You know, it's in the same vein as.
Yeah, well, if it's part of the image, perhaps we could clear up that by saying, look, if it's part of the image and it's not, like, then it's no longer configuration. But if it's in addition to your image, it's something that we, you know, like the container can be the same image but different metadata. This is the same kind of thing. And again, we have a wide range of Ts. Some are containers, some are VMs, and some are, you know, enclaves. And then who knows what the future will bring. I just want to be able to catch the case that sometimes the image doesn't have everything.
Okay, that sounds good. Just as we're wordsmithing that, take into account that there are some config items that affect security, that especially in an OS that are very broad, and they need to be measured as well.
The first two bullets already make exceptions for if something is hard-coded into the payload, then it's already measured and attested, so don't worry about it. But if it's not, then if it's an addition, then you need to make sure that it's also part of the attestation. All right, so I think that's it for this, we also need to, this is the last thing, is we need to make sure that all the personas, because remember we have this other document that describes the different personas in the governance space and how they relate to each other. We should, at the end of each pattern, basically say, how does this pattern affect these personas? You know, what do they need to do in responsive to this pattern that, you know, they may not have done otherwise? And again, I already asked Sal to, you know, perhaps suggest some words, but if you're, maybe I can remind you where the personas things are. Hold on. Oh, there we go. This is the document that I was hoping to reference. And I'm kind of anxious in the last 15 minutes to target workload upgrades, but it's this guy. These are the 6 classes of participants in the space. We can basically say this is how AVS providers are affected by this pattern. This is how auditors are affected by this pattern, their expectations, etc. As this can help folks like the likes of which write FFIEC handbooks for auditors. Okay, so I would like to now switch gears and talk about the workload upgrades. So let's do a very quick 5-minute review of this. Again, putting the link in the chat. And again, I would like to get this document to the point where we can you know, sign off on it. It's a short one. But again, 50 minutes past the hour is when we'll take a look.
What does AVS stand for?
Attestation verification service.
Ah, okay.
All right, we're at time. So, any comments on this? Sal, same question to you as on the previous one. I just added these sections to the end, personas and references. It's basically the same stuff, just listing a few bullets on the changing expectations.
Yep. Perfect.
Would be
Will
very
do.
helpful if you could do that.
I need edit access to this document. I've sent it to
Okay.
and then I will do.
Surprising, because it's all in the same GRC. I just granted you access.
Yeah, not sure. Sometimes I'm having some weird permissions issues, but should be
Yeah.
good now.
Yeah, it's fine. But you have access.
I do. Cool.
The integration of Slack with the Google Drive is quite. I could literally do it with one click. Great. All right. So I hear lack of feedback that we are pretty much okay with it. So again, next time we meet, I would like to drive this document to completion. And so after that, we send it to the TAC and move on to other patterns in our set. Now, which ones we'll decide next time.
Yeah, that sounds good. I think this document it looks pretty straightforward and pretty solid. The other document, one thing that did come up in CSA when we reviewed it yesterday was that we might consider pulling out and sort of separating more clearly as a separate pattern the sort of vulnerability management and the reproducible builds from that section. Does anyone have any strong opinions about that or not?
Well, I think I mentioned yesterday incorporating an external document by reference is probably fine.
Great. Okay, cool. Okay. Yeah, then we can finish up these two. And I do want to say for the remote attestation part, I've got 30 minutes of Dan's time today. So I'm going to get his technical opinion on it.
Okay, sounds great. Okay, one last thing I want to bring up. So I will probably cancel the next meeting, because, or maybe Sal, you can do it if you have access to, like I'm not the scheduler of these things, but because of RSA, we, it's probably something that we would have to skip, because not enough people are in that. But we'll meet in 4 weeks. The thing I want to bring up next, and I brought it up in CSA meeting yesterday. So the new FISA authorization bill that just made it through U.S. Congress is basically a warrantless surveillance, Fourth Amendment busting thing. Though basically they did a subtle change where they said if somebody is a custodian of a computing device, which broadly interpreted could be your, housekeeping in a hotel, or the cable guy, or pretty much anyone with access to, they can be compelled by the government to, basically spill all the beans about the device's contents, and can also be prevented from speaking about it. Does not require warrant. There is no due process, etc. But confidential computing is a mitigating factor for some of this stuff, and I would like to have some kind of a position paper in place that explains the limitations of confidential computing as a mitigating factor. For instance, if NSA and Intel have a backdoor agreement that is not made public, then all bets are off, and we're not going to handle that. Or if the signal protocol itself is backdoored because it's been funded by CIA and had this Catherine Marr character on its board, not exactly believers in free speech. then again, it's all bets are off. However, under a set of assumptions, we can basically say confidential computing can be a mitigating factor. It's something that I would like to be able to do in the next few weeks, offer as a position paper, and explain different sort of configurations, limitations. I don't know if anyone is willing to, is interested in collaborating on that.
It sounds super interesting. I don't know enough to offer much of a informed opinion. I don't think, I mean, what I remember before from FISA is that there is a FISA court and that you do have to have a warrant from the FISA court. Granted, it's not, I mean, it's a court of spooks, but it is a due process that meets constitutional requirements. So we'd have to be super careful as, to word it with established law, because otherwise it's going to just sound like a rant.
Well, point taken, but there is, so the Electronic Frontier Foundation, the Free Press Foundation, effectively civil libertarian groups who read and analyzed this are very much up in arms about it. People are very unhappy. And again, I'm not a lawyer. I basically recited what my understanding of this is.
Yeah, I've read a few editorials that roughly align with what you said.
Right. So anyway, but that's I don't want it to sound like a rant. I just want sort of a sober assessment of the degree to which confidential computing can thwart attacks that result from physical possession of a device. Sort of what's in scope, what's out of scope. We're not a civil libertarian organization, so we don't need to be sounding alarm. We don't need to be taking a political stance. But it's important to understand that this is a security technology. What impact does it have in a case where somebody grabbed your device? That's really the context. This is not about, FISA bad or anything like this. It's I don't want to get into the politics of it. You can probably guess what mine are. I suppose if they weren't what they are, I wouldn't be in this group.
Right. I think that you could say that about any of us.
But yeah, but that's that's something I think we owe to the world, because we are the experts in this technology. We could probably explain it better than anybody. All right, so I'm gonna give you guys 3 minutes back, and I will see you all in 4 weeks.
All right, cool. Thanks. Bye.
All right, thank you. Bye-bye.